Okay, in this video we're going to look at drawing angles in standard position. On a previous video we looked at what it means for an angle to be in standard position. We said that the vertex has to be at the origin and the initial side is going to run along the positive x-axis. So we're going to look at actually sketching or drawing some of those angles. Also remember that positive angles open to the left or counterclockwise, so in this direction, and then negative angles open to the right or clockwise in this direction. So example 3, draw and label each angle in standard position. I'm going to start with my initial side already in the picture. So for this video, you'll see the initial side along the positive x-axis and the vertex already at the origin. So here we have, this is the lowercase Greek letter alpha. It looks a lot like the lowercase letter A, is pi over 6. So we're going to draw pi over 6 radians in standard position here. Now, again, until you get more comfortable with some of these common radian measurements, it might be more helpful to convert this pi over 6 to degrees, and we saw that in the last video would be 30 degrees. So we're going to draw a 30-degree angle here. Notice it's positive, so we're going to open up to the left or counterclockwise. So we're going to start by opening it up towards the positive y-axis. And when we do that, here's our terminal side. Now, when I'm looking at these, when I'm grading them, I'm not going to put a protractor to your sketch to make sure it's accurate in terms of, did you draw really a 30-degree angle or is it more like a 32-degree angle? I'm looking for two things. Number one, is your terminal side where it needs to be? So is it, in this case, I'm looking for it to be in quadrant 1. And then secondly, to indicate the direction that you rotated. So it might be a little bit tough to see, but this one is going, this arced arrow is opening up counterclockwise. If you want to label it as well, you can, you don't have to, but I do need to see the terminal side in the approximately the right spot. If it's a quadrantal angle on one of the axes, then I need to see it on one of the axes, and then the direction at which the angle is opening, or the direction of rotation. Part B, we have beta, this is lowercase Greek letter beta, equals negative 4 pi over 3. So we had alpha for the first Greek letter. This is the second Greek letter beta, alpha beta, which is where we get the word alphabet. So this time we have negative 4 pi over 3. So let's convert that to degrees. And when we do that, we get negative 240 degrees. Now it is negative, so instead of opening to the left, we're going to start by opening to the right. So let's count out about 240 degrees. So this would be 90, 180. This would be 270, so it's somewhere in the second quadrant. In fact, if we go 90, 180, it's about 60 more degrees going to the right, opening up to the right from this negative x-axis. Again, I'm not going to look for it to be spot on perfect, but I would want to see a terminal side for this problem in the second quadrant. And then just indicate the direction that we rotated. You can use the arrowed arc, and I just label it because that's force of habit. But so there's beta in standard position. All right, part C, this is the lowercase Greek letter gamma. Looks like a lowercase y, but it's the third letter of the Greek alphabet. Lowercase Greek letter gamma is negative 9 pi over 4. So let's convert that to degrees as negative 405 degrees. So we know we're going to open to the right because it's negative. This is 90, 180, 270, 360. This one goes beyond one full spin. So it goes 360, but then it doesn't quite make it to 450. So it's going to end up in this fourth quadrant. And because we had more than one full rotation, rather than just stop when we get back to our initial side, we have to keep going. And what we're going to see is that if our angle is above 360 degrees or below negative 360 degrees, it's going to start to spiral out. So it started opening up to the right. Here's one full rotation of 360, and then another 45 degrees to get 405 degrees. And again, notice the way it's going to the right, indicating a negative angle measurement. All right, finally, 3D, this is the lowercase Greek letter delta. Equals negative 5 pi over 2. So let's convert that to degrees is negative 450 degrees. So we're going to rotate 360 and then another 90. And notice that we're on the negative y-axis. So quadrantal angles, I will make sure that, I'll be looking to see that they're on the correct axis. In this case, the negative y-axis. And this time we're opening up. Here's one full spin and then another 90 degrees to make the negative 450 degrees. All right, so that about does it for this video. Thanks for watching. I'll see you next time.